Hi everyone, myself Amrutha, Assistant Professor from Department of Computer Science, St. Albert's College, Autonomous. Today we have been going to have a session from operating systems, the scheduling algorithms, that is mainly focusing on the priority scheduling algorithms. So in the previous lecture we already discussed about how we can perform FCFS scheduling algorithms and all. So today we have been going to discuss about the priority scheduling algorithms. In the previous lecture, we already discussed about the FCFS scheduling algorithms and the example for the FCFS scheduling algorithms. So now let's move on to our topic, that is the priority scheduling algorithms. So what is priority scheduling algorithm is the PU algorithms that schedules the processes based upon the priority. Priority means all the processes which will be assigning a number. The number represents the priority. If it commonly how we are be doing is the lowest number which represents highest priority. The process which having a lowest number, that process is having a highest priority. So that process will be executed first. So and there may arise another question, that is, if different processes having same priority, what will we do? In such cases, you perform which in the FCFS order. Which process comes first? If two processes having the same priority means if which process comes first, that process will be executed first. So it can, in the priority scheduling algorithms, it can be of preemptive and non-preemptive scheduling algorithms. Whereas in the FCFS scheduling algorithm, it can be of only non-preemptive scheduling algorithms. So priority scheduling algorithms, the preemptive version, it is best suited for the real-time operating systems. So one of the disadvantages of the priority scheduling algorithm is the starvation. So what is this starvation is? The process which is ready to run can wait indefinitely because of the low priority. So suppose you think that in the ready queue, all the processes which having a high priority process. So this lower priority process wants to wait for a long period of time. That means it doesn't get the CPU for its execution. It starves for the CPU for a long period of time. That condition is known as starvation. So since all the higher priority processes are in the ready queue, this lower priority process waits for a long period of time. So that condition is known as starvation. So how we can solve the starvation is that it can be solved by using a technique, aging. So aging is a method to ensure the process with low priority will eventually complete their execution. So now let's check it how we can perform the aging. So I already told the aging is a technique which is gradually increasing the priority. We are increasing the priority of a lower process in order to get the CPU for its execution. So let's check it with an example. Suppose these all data are given for process P1, its priority is 100, whereas P2 it's 1, P3 is 1, and there are since a lot of processes in between 100. That is, I already told with the lower number which represents the higher priority. So P2 which having a lowest number 1, so it's having a highest priority. So P2 will be executed first. Since it's having a burst time of 7, it will be executed first. Then P2 is having a priority second priority. So P3 will having 10 milliseconds, and after P3 execution, since there are lots of processes in between 1 to 100, there are lots of process 1 to 99 process. After running only, the P1 will be executed first. Only after execution from P2 to P2, only after its execution, only the P1 get the CPU for its execution. So the P1 want to wait for a long period of time, since there are higher priority processor in the ready queue. So what will we do is, I already told that in the starvation we can solve the by using the technique called aging. So how we can perform is that, so you just increase the priority by after a particular interval of time. Suppose I am just increasing after 1 units of time. Just increase the priority means decrease the number. So after 1 units of time, just increase the priority as decrease the number, that means 99. So now the priority has been increased. So next, after you can choose that particular period and what amount of time and what amount of units to be decreased you can be designed. Suppose if you want to decrease after 5 units, just decrease 5 units of priority, then it will becomes after 5 units 95 will be the priority of the P1. So likewise, just increase the priority till that process process P1 just get the higher, becomes a higher priority and gets into execution. So this is a technique called aging. In the case of aging, we are performing just increasing the priority after a particular interval of time. So now let's discuss with a small example how we can be perform the priority scheduling algorithm. So here there are 5 processes are given and whose burst time and the arrival time is also been given. This is a non-preemptive priority scheduling algorithms. So first of all, we are going to discuss about a non-preemptive priority scheduling algorithm. So first of all, we want to draw the Gantt chart for this process. So first, they are at time interval 0. P1 has been arrived. So its execution time is 4 units, but its priority is 4. So first, this priority scheduling algorithm is based upon the priority. So here we want to check it. The highest priority P5 is having highest priority and P1 is having lowest priority. But P5 is arrived at time interval 4 and but P1 is arrived at time interval 0. So at between this 0 to 4 we can be execute this P1. So first of all, the at arrival time 0, P1 has arrived. So just put P1 as the first process, and this is a non-preemptive version. So only after the execution of the P1 it just looks on which process has arrived. So after the 4 units of execution time, all the process has been entered into the ready queue. So now it is based upon the priority, choose on the processes. So next, after P1 execution, P4 will be chosen, then P5 will be chosen, and next P3 and last P2 will be chosen. Can be seen in the Gantt chart. So after the drawing the Gantt chart, it is very easy for the calculation of the turnaround time and the waiting time of the processes. So turnaround time, which can be calculated as completion time minus arrival time, and waiting time, which can be calculated as turnaround time minus burst time. So first, can you calculate the turnaround time? So turnaround time of each process wants to be calculated. For example, the turnaround time of P1, which is completion time minus arrival time. So the completion time of P1, it is 4 units and its arrival time is at 0. So 4 minus 0, which is equal to 4 itself. And likewise, you perform all the processes turnaround time, and after calculating the turnaround time, which can be calculated the average waiting time, the waiting time of each process can be calculated as turnaround time minus the burst time, which is already given in the question. So you calculate the waiting time. After that, just calculate the average turnaround time and the average waiting time of each process. So this is an example for non-preemptive version algorithm. Non-preemptive version means only after its execution. We don't want to check each time interval. Only after its fully execution only we are considering which work processes are there in the ready queue. So now let's check it with an example of priority scheduling with preemptive version. This is an example for preemptive version. Now let's check it how we can perform the preemptive version priority scheduling algorithm. Here also lowest number which represents the highest priority. So P5 is having highest priority and P1 is having lowest priority. But the arrival time, you also want to check out if the arrival time is given, you want to check this arrival time also. So here P5 is arrived at time interval 0. But before that P1 at time interval, P1 is already there. So you can execute P1. So first of all, P1 has arrived, and after each execution, after each time period, you want to check. So after 1 units of time, after that time interval 1, you please check it out where any other process has arrived. So here a time interval 1, P2 has arrived, and we want to stop P1's execution because P2 is having higher priority than P1. So you choose P2 into the execution, and P1 now goes to the ready queue. So now the execution of P2 will be going on, and after time interval 2, you just want to say, I already told, want to check at each time interval, we want to check if any other processes be there is having a highest priority. So at time interval 2, P3 is there. So P2 stops execution and gives its execution CPU execution turn to P3. At time interval 3, P4 has been executed. So which having a highest priority. So it now at time interval 4, after execution at the time interval 4, P5 has arrived and which having a highest priority. So then if once all these processes has been entered into the ready queue, now based upon the priority, the algorithms will be scheduled. That means the processes will be scheduled. So you will be getting a Gantt chart like this. From once you have been get this Gantt chart, it is very easy for to calculate the turnaround time and waiting time of each processes. So calculate the turnaround time of each processes by the completion time minus the arrival time, and the waiting time also been calculated as the turnaround time minus the burst time. So just calculate the turnaround time and waiting time of each processes, and at last find out the average waiting time and the average turnaround time for the process. The average waiting time and can be calculated as the total number of waiting time by the number of processes. Since there are 5 processes, it will be divided by 5. Likewise, turnaround time also been calculated, total number by the number of processes in that. So by the end of the session, I think you all been familiar with, you all understand what is a priority scheduling algorithms. The priority scheduling algorithm is very simple. It is based upon the priority the CPU is allocated, and here we have already discussed about 2 examples based upon the priority scheduling algorithms. The preemptive version and the non-preemptive version can be discussed with an example. So I think you all be clear about the priority scheduling algorithms. Thank you.